Alright, welcome to question 10. Given a line passes through point A, 5, negative 8, B, 2, negative 2, C, negative 1, 4, and D, negative 3, 8. Right triangles are formed using segment CD and segment AB for respective hypotenuses. Prove that the distance of FC divided by the distance of FD is equal to the distance of EA divided by the distance of EB. This will prove that the slopes of segment AB and the segment CD are the same slope. So this is very similar to the last one, and so we can use the last one as our reference if we would want to. So we have the points here: A, 5, negative 8, B, 2, negative 2, C, negative 1, 4, and D, negative 3, 8 are all on the same line. That's given. FD is equal to 4 and EB equals 6. Well, again, how do you find the length of a segment, FD and EB? FD and EB, you would have to use a distance formula very similar to what we did in the very first one. So this one is going to be distance formula. Points F, negative 1, 8, and point E, 5, negative 2 are constructed to create triangle CFD and triangle AEB respectively, intersection of blank line segments. Well, if you were to scroll back to 9, remember that we had FD was a vertical line and FC was a horizontal line, and that's how it created this triangle. So I'm going to use that and see if there's the intersection of vertical and horizontal line segments. So blank 2 is going to be vertical and horizontal. They did have that. So yes, we had vertical and horizontal line segments intersect to create triangles right here and right here. So blank 3, vertical and horizontal lines are perpendicular. Okay, so I would be looking for the vertical and horizontal lines are perpendicular. Perpendicular means 90 degrees. So I'd be looking for like FD is perpendicular to FC, since we have our vertical line and our horizontal line. Likewise, I'd be looking for EB is perpendicular to EA, since again we have our vertical line and our horizontal line. So for blank 3, I would be looking for perpendicular symbols. So I have some. FC is perpendicular to FD and EB is perpendicular to EA. Yes, even though this FC in their statement is first, in mine it's last, that's interchangeable. It's okay. So now going back to blank 4, blank right angle theorem. So again, if you aren't remembering it, we did see right angle theorem here. So using the right angle theorem, it can be shown blank. Using that theorem, we showed that those two angles were congruent. So I'm going to go back and I'm going to be looking for what those two angles are. That angle is DFC. So DFC is going to be congruent to BEA. So that's what I'm scanning for blank 4. Oh, okay. They only have angle F is congruent to angle E, which that simplifies it. So angle F is congruent to angle E. Yes, that is true. Blank 5 is equal to 3/2, and the distance of EB over the distance of FD is equal to blank 6. Simplify. Okay, the way I'm going to look for blank 5 is I'm going to look at where is EB and FD. So EB is this vertical line, and FD FD is also the vertical line. So now I am going to check that the one before is EA over FC because it's horizontal line comparing to horizontal line. And this would be 1, 2, 3, and 1, 2. So it would be 3 over 2. So again, this would be EA divided by FC. So EA divided by FC. And blank 6, EB divided by FD is equal to what? So EB is 1, 2, 3, 4, 5, 6. So 6 divided by 1, 2, 3, 4. So 6 divided by 4, that could reduce down to 3 halves. So I'm either looking for 6 divided by 4 or 3 halves. The reason I might consider 3 halves is because of this word right here, simplify. So blank 6 divided by 4 or 3 halves. Oh, it has both of them. Good. Alright, so blank 7, blank, side angle side similarity theorem. So I'm looking for a triangle. BEA is similar to triangle DFC. Triangle CFD. Alright, so we have those two now. So then the ratios of corresponding sides of blank are proportional. So segment of FC is equal to, divided by segment of FD is equal to segment of EA divided by segment of EB. So ratios of corresponding sides of, we just proved that we had similar triangles. So maybe we have similar triangles there as an option. We do. So the ratios corresponding sides of similar triangles are proportional. So I hope that helps, and I hope that you could see how I used the previous question to help me go through these statement and reason ones. So